Let us take a look at LeetCode question number 200 called as number of islands. So we will be given a matrix of n by n dimensions, two-dimensional binary grid, which will be in form of character array, and it will represent 1 as land and 0 as water. And our job is to return the number of islands. So the definition of island is: an island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. This is important, horizontally or vertically. You may assume all four edges of the grid are surrounded by water, which means anything outside this grid is water. So we don't have to consider anything about it. Now let us take an example. This is the grid, output is 1. Why is that? This all 1 represents an island, where 0 represents a water. So now you are told that you can move horizontally or vertically and find that island. So if you are at this coordinate, then you can go to this coordinate as well as this one, traverse down, traverse right, and traverse down one more time, which will contribute to one island only. So this all ones, this one and this 4 ones coordinate to only one island. Let us take a look at second example. This will make things much more clear. Take a look at these elements, these 2 ones and these 2 ones, and they are surrounded by water. This 0 0 over here and this 0 over here. So this is one island. Remember, we can just traverse horizontally or vertically to get the island, not in diagonal, which means that these two can be different islands, right? Now take a look at this one, and this is surrounded by 0 0, this 0 and 0, which means this is another island. So this one was first, this is second, and this is the third one. In order to go ahead and implement this solution, we have to understand that we can just leverage a concept of depth first search or breadth first search and consider this grid itself as a graph, where you can say that you are at the first coordinate, and you can say if it is 1, then I am at the island. So number of island is equal to number of island plus 1, and just traverse and check if any other ones are available. If yes, then the count is already taken care of. If no, then you have to repeat the loop again. So let us go ahead and implement the DFS algorithm for this one. And there is also another problem, that if you have traversed that island, how will you know that you have traversed that particular island? So you need visited array, or you can go ahead and modify the input itself. There is no such constraint provided to us saying that we cannot modify the input. So we are at discretion to go ahead and just modify the input. So let's say if you are at this place and you encounter this island, you can just go ahead and say that this particular value, I'll just mark it as 0, which means it's a water now. Don't consider it as island. So you can do that, or you can go ahead and create a boolean array, two-dimensional array, and maintain status of each and every one, that this island is marked or it is not marked. So if you use additional array, then you run into more space complexity, which is completely fine. You can just go ahead and do that also. So let us take a look at our first solution using depth first search, and we will not use any auxiliary array. We'll just change the input itself, as there is no constraint saying that we cannot change the input. So let us take a look at depth first search. So let us first write the base condition, that if grid is equal to null or grid dot length is equal to 0, return 0. So this is the base condition, right? If we don't have the proper grid, we just say return 0. And int count is equal to 0. This is something that will return. And let us just traverse the grid now. I equal to 0, I is less than grid dot length I plus plus, and for int j is equal to 0, j is less than grid of 0 dot length j plus plus, and if grid of I and j is equal to 1, then we can say count plus plus and do depth first search from here. For this we will need I, j and grid. Now let us write the first search. We can say private void tfs int I int j char array grid. That is all. And now we have to be careful that this I and j, whenever we are traversing in the first search, that they are not out of the bound. So let us just first write the condition of marking the territory as visited. So we will mark the current territory as visited. So we can say grid of I and j is equal to 0. So this is mark as water. And now what we will do is we will move our current state of island to left, right, top and bottom. And in order to do that, we can have different directions like this. And I will define directions array. So we can define it and we can say from here tfs, then we have I plus dir of 0, j plus dir of 1 comma grid. That is all. Now we don't need anything more than that. Now this, whenever you call this dfs method one more time from here, this can go out of the bound, right? So we can write condition over here that if I is less than 0 or j is less than 0 or I is greater than or equal to grid dot length or j is greater than or equal to grid of 0 dot length or grid of ij is equal to 0, then you just say return. Don't do anything. Okay, so this is the base condition. This means that we are in the right island and we don't run into any array index out of bound exception, and whatever count we have over here, we'll just return it. So that is it on dfs. Let us run this code. So this was okay, this worked fine, but see that we are destroying the input over here, right? So once this method returns, this grid will be all zeros, so if nobody can use this object anywhere. So what we can do is we can go ahead and use something called as visited array. And how to do that is like this. You can have boolean visited array, visited equal to new boolean, and the length of that would be grid dot length, and this one would be grid of 0 dot length. And what we will do is we'll pass this grid also over here, visited, and we'll mark this visited as true. Okay, and another thing to do over here is, and this is a common thing that sometimes we forget, is usually we have to put condition over here also for visited array, that if this I and j is not visited, like this, if it is not visited and grid is 1, then only visit it, because when you come back again, grid can be 1, right? Because what will end up happening is we are not destroying any input. So if it is not visited and the grid is equal to 1, then only go ahead and visit it. And over here we are marking visited as true. Okay, so this worked fine. Now this was depth first search. Now we will try to solve using breadth first search, and in breadth first search we will use queue data structure on our own, and we will write something similar code. So you just need to understand that these are two different ways to solve a problem. One is DFS, depth first search, and another will be breadth first search. And in DFS we solved using visited array and without using visited array. So let us see how we can solve this problem using breadth first search, and in the first part we'll go ahead and change the input. So let us start writing the code using breadth first search. I'll just go ahead and remove few things. I'll remove this visited array, this condition, and this DFS. and I'll just write down over here as, let me just do this, let me just remove everything from here like this, and I would say BFS using grid, private int breadth first search character array grid, and int count is equal to 0. Now in BFS we use data structure queue, and what we will do is we will store current coordinates, that is I and j value or row and column that has been processed. New and linked list. You can use any queue data structure, I'm just using linked list right now. I is equal to 0, I is less than grid dot length and I plus plus, and for j is if our grid of I and j is equal to 1, then we'll say count plus plus, we found an island, and we'll insert this particular coordinates I and j into linked list, or in queue, better to say in queue. And once we do that, we would just mark this coordinate as visited. Okay, mark it as visited, and we are marking it as visited using by modifying the input. And while this queue is not empty, we have to explore all other neighboring islands. So in order to do that, we can say int current coordinates is equal to q dot poll, remove the first entry, and dir to directions int current row is equal to cur of 0 plus dir of 0, and column is equal to current of 1 and directions of 1. And if row is greater than or equal to 0 and column is greater than or equal to 0 and row is less than grid dot length and column is less than grid of 0 dot length and grid of this row and this column is equal to 1, then q dot offer new int r and c, and grid of r and c is equal to 0. Mark it as visited. Okay, many things went around over here, so let me just explain you what really happened. So as soon as we found the first island, we marked the island as we found one island, we'll just increment it and we'll add the current coordinate in the queue. As soon as we do that, we'll mark the current cell as 0 and we'll move ahead on finding any different adjoining cells, whether they are island or water. If they are island, then we have found more islands and we have to keep on processing them, and then only for the next iteration we'll mark the number of island as true. For this one we will not mark it as true because all of them are co-joining. So we remove the first element and we went through all the directions. These are the 4 directions that we can go. We went through all the 4 directions. We found the new row and found the new column. We made sure that this row and column are within the bounds and is not yet traversed, and we will input those in queue. Now this is important as we have to make sure that whenever we try to do, we will mark that as visited, else our output will be wrong. So that is it on breadth first search solution. So let us run and see what really went into this. Let us run the code first. Missing return statement. Oh, great. Return BFS test case. This one. Okay. Let us submit this thing. Okay, so this also worked. Now we solve this by using this grid, and we change the value of the grid. We will solve the same problem using visited array, and in order to do that, we'll just take this boolean of visited equal to new boolean array, and the size will be grid.length, grid of 0.length, and over here we'll say if it is not visited, and the grid is 1, then we visit it and we mark it as true, that we have now visited this one. And that is all. We have to change this if condition also. If it's equal to 1 and visited of ij. If it is not visited, then only go ahead and use it. Okay, something went wrong. Row and column. That is all. Thank you.